In the 20th century, a scientific journey that would forever change our understanding of the universe. The evolution of quantum mechanics. At the dawn of the 1800s, classical physics, governed primarily by Newtonian mechanics, had been the superstar of scientific inquiry. It explained celestial motion, mechanics of solids, and even aspects of thermodynamics with astounding precision. The universe seemed a calculable machine, where every gear and cog behaved predictably, leaving little room for randomness or uncertainty. However, as the 19th century waned, this precision unraveled with the intriguing anomaly of black body radiation, which be known as the ultraviolet catastrophe. Classical physics anticipated that a black body would unleash an infinite amount of energy at short wavelengths, a prediction that starkly opposed experimental observations. The catastrophe prompted Max Planck in 1900 to propose a groundbreaking solution. Energy is not continuous, but rather quantized, emitted in discrete packets he called quanta. On its heels came Albert Einstein, who, in 1905, extended Planck's quantum hypothesis to explain the photoelectric effect. Einstein posited that light itself was quantized, consisting of photons, and each photon carried energy proportional to its frequency. With this, he pointed the way to the wave-particle duality of light and laid the foundation for quantum theory. The 1920s unveiled further quantum revelations. Niels Bohr introduced his model of the atom, incorporating quantum ideas to explain electrons' quantized orbits around the nucleus. Though revolutionary, it was plagued with limitations and perplexing quantum behavior. Erwin Schrödinger and Werner Heisenberg soon took center stage. Schrödinger's wave mechanics and Heisenberg's matrix mechanics offered alternative formulations of quantum theory, explaining phenomena such as electron diffraction and chemical bonding. Their mathematical formulations paved the way for the creation of quantum mechanics as a structured theoretical framework. Heisenberg also introduced the uncertainty principle in 1927, highlighting a fundamental limit to what can be known about the quantum realm. Suddenly, the determinism of classical physics yielded to a universe painted with probabilities. Though counterintuitive and abstract, quantum mechanics thrived on these principles from Paul Dirac and Richard Feynman. Dirac's formulation unified quantum mechanics with special relativity, while Feynman's path integral formulation provided profound insights into quantum field theory. The evolution didn't end here. Quantum mechanics spurred technological advancements, from transistors to MRI machines, revolutionizing industries and modern life. Quantum entanglement and computing promising future waves of innovation and philosophical contemplations. Thus, the evolution of quantum mechanics is a testament to human ingenuity and curiosity, urging us always to ponder, explore, and redefine our limits.